So for this part of the tutorial, what we're going to do is get the ball and we're going to add a constant rolling sound effect to it. And this rolling sound effect is going to just follow it around and it'll always be attached to the ball. But we're then going to modify this sound so that when the ball stops, it stops. And when it starts again, it starts again. And according to how fast the ball is currently rolling, we'll shift its pitch and we'll shift its volume just a little bit. So how do we do that? Well, we begin by getting this pinball rolling sound, right-clicking, and creating a cue. I'm going to get rid of the 0, 1 on the end of the cue here because it's unnecessary. At which point, I'm going to open it up, and we've initially got this, which is just a basic rolling sound. However, one thing that I would like to do here is I want to click on this, and you'll see that we have an option called looping that I can just enable. So I'm going to turn that on. Now, it's important to note that when we're using a cue file, you need to do your looping in here rather than on the wave itself. Another way to do it is to type in the word loop, and you can see that we can set up looping here as well. But for the time being, it's easy enough to just set it up on that. So now that I've got that set up, I'm going to go Attenuation Settings, Pinball Attenuation, and Save. After closing this asset, I'm now going to open up Blueprints again, and I'm going to go to the ball blueprint. So from here, I'm going to add a component. So by adding a component that's an audio component, I'm adding a sound that will be constantly set to wherever the ball is. And this is just going to be called ball rolling sound. And I'm going to set the sound to be the cue that I just created, which will be ball rolling cue. Now, the quickest way for me to do the functionality that I spoke of is to in tick add a sequence so that sequence 0 goes ahead and fires off the impulse that we would normally use, but sequence 1, so the next value down, is now going to trigger something else. It's going to go down here and modify the rolling sound according to the current world variable. So I'm going to get the ball rolling sound and I'm going to drop it in by holding Control and left click. From here, I'm going to type in the word volume, and you can see that we have an option called Set Volume Multiplier. So the first thing that I'm going to be doing when I make this is I'm going to modify the volume of the sound. The next thing I'm going to do is I'm going to set the pitch, and you'll see that we have Set Pitch Multiplier. Now both of these are just after a float, and we've got to think about how we actually want to get that float. What is that value? So effectively we want the volume to go up to 1 when it's at a reasonably quick speed, and we want it to scale back to 0 when it's beneath that speed. So the simplest way for us to do that is actually to get the velocity of the ball. And now this velocity of the ball that we get returns a vector. So it's giving me the velocity in x, y, and z axes. But in this case, I actually just need the general velocity of the ball. I don't care about any of the other details. Like I don't care which direction it's currently really moving in. I just care about the overall velocity. And to do that, we need to get the length, vector length. So this returns a single float value that's going to be the speed of the ball. Now the next thing that I'm going to do is when this is going at a reasonably quick speed, I want to have this set to 1. So the quickest way for me to do that is to say, let's pretend we want a speed of 1,000 to equal a volume multiplier of 1. So to do that, all I need to do is get the length and divide it by a number. That number is 1,000. At which point, when the speed is equal to 0, this number is going to be equal to 0, because it'll be 0 divided by 1,000. When this number is equal to 1,000, it will be equal to 1. Because 1,000 divided by 1,000 is equal to 1. The final thing that I'm going to do is I'm going to clamp. So a clamp, when you run a number through it, what it essentially does is it makes sure that if a number is below 0, or below the minimum, it will equal this number. When it's above the maximum, it will equal this number. And by plugging this into here, it means that if the number were to somehow ever be below 0, it would be equal to 0. And if the number were ever above 1, it would just be equal to 1. So even if this is moving at 2,000 units per second, it would now be equal to a value of 1. So we've got our volume set up, and I'm just going to do the same thing for the pitch, but this time I'm going to set the min to be 0.97, and I'm going to set the max to be 1.2. Plug that in, and connect that to pitch. So with that plugged in, I'm going to compile and save, and when I launch the game, so I can hear it, but it might be a little tricky to hear over the music. So I'm just going to turn the music off for just one moment so we can verify that it's working. So I'm just going to disconnect my music over there for just one moment. Yep, it's definitely working. So as the ball moves, wonderful. So now we have a ball that's dynamically modifying its pitch and volume accordingly. I'm going to connect this again so that we've got something there. Might even consider turning these down just a little bit more. I'm going to compile and save. At which point, this is now done for the ball. So that's all it took to get some dynamic modifications to a file. Now, if we wanted to do this with a sound that we had created, we could do it in a number of different ways. But the most important thing to note if you were to do it is when you create a sound from one way or another, here we go. When you're creating the sound, it spawns a reference to the audio component. So if we wanted to modify the ball loose option for some reason, we would just promote that to a variable, and then we would modify that variable at runtime as the game was running. So we could do it with dynamically created sounds, but for the time being, that's all we really need to have. It's just a ball rolling sound that's always there, because there's never a situation where we want it disabled. So that's it for dynamic audio components.